All right, so once again, for home plate tonight, you have only of those 10 problems. Only. So, be nice. So, it says home plate. Find the distance between the 2 points. Each pair of points. You need to find the distance. I'll show you how to do that in a little bit. But let's get started. On your Cornell Notes, copy the objective, please. Bottom left. And it says, I can solve for the missing side of a right triangle using the Pythagorean Theorem. Let's read together. 1, 2, 3. I can solve for the missing side of a right triangle using the Pythagorean Theorem. Pythagorean Theorem. All right, so since the screen's still messing up over here on the projector, the concepts for today are right triangle and the Pythagorean Theorem. Okay, so for your Freire model, you're going to write right triangle. Oh, triangle. Okay, and then I'm going to elaborate in regards to the Pythagorean Theorem. So, Freire model, yeah. So, right triangle. What is it? A triangle with one 90-degree angle. What is a right triangle? A triangle with a 90-degree angle. What is a right triangle? A triangle with one 90-degree angle. What does it look like? Like these. And let's see. I'm going to identify on each one of those the 90-degree angle. This one has it right here. This one has it right there. And this one has it right there. Well, you can't really tell on the... Let me change the font. No? No. Oh my goodness. Is that better? Yeah. There it is. Those are right angles. All right. Also, before I move on to the definition really quick, right triangles have 3 sides, but the 2 sides that join to give us the 90-degree angle are known as legs. The 2 sides that join together to give us a 90-degree angle are known as legs. So that means this one and this one are legs, this one and this one are legs, this one and this one are legs. All right. So those are legs, which leaves us with one side that is not labeled. You guys notice that? The side that's not labeled, that is not part of the legs, that longest side is known as the hypotenuse. Hypotenuse is the longest side of a right triangle. The longest side is known as a hypotenuse. The hypotenuse is the longest side of the triangle, right triangle. Now, what else can you tell me about the hypotenuse? The hypotenuse is located right across from the 90-degree angle. Here's 90 degree, look, and across it is the hypotenuse. Here's a 90 degree, across it is the hypotenuse. Here's a 90 degree, and across it is the hypotenuse. Okay, now that we located all that, let's go back to the definition. It says, a triangle with one 90-degree angle. Another word or another term that we use for 90-degree angle is a right angle. So that means if a triangle has one right angle, it is known as a right triangle. That's kind of obvious, right? Get it right? Get it right?
Oh, dang, I got it.
All right. So any questions on right triangles? All right. Can you give me a non-example, Marissa? Bam! Watch out! Woo! Another non-example. Devin. Wow! Watch out! How about another example? Isaac. Oh, an acute triangle. So here's an acute triangle. So an acute triangle is a triangle that has the three angles that are less than 90 degrees. So this angle is less than 90 degrees. This one is less than 90 degrees. This one is less than 90 degrees. So yeah, I'll take that. I'll take that. That's fine. Get a hashtag going for. We need a couple at least.
Me.
Okay, go ahead, Jason. 90 degrees. Anyone else?
Me.
Julian?
B stretch.
What? B stretch? Okay. Marissa? Oh, be right. Oh, be right. How about hashtag triangle? Bam. Can you believe that? Woo! That was like way out there, huh? All right, underneath that, I want you to write steps. And for the steps, you're going to come up with those as I go through the process, okay? But before I get started with all that, let me just kind of like briefly introduce the Pythagorean Theorem. So, here it goes. Like I had mentioned before, back in the medieval times, mathematicians were considered wizards, right? Remember I told you guys some time back the story? And why? Because they would be able to kind of like use mathematics to determine how long some troops will get to a certain kingdom by using formulas. Well, when they predicted, well, that troop's going to get over there in 3.5 days, and when they arrive in 3.5 days, everybody's like, what? They can predict the future. So what happened was the most known mathematicians that were really good at their math, they started becoming threats to kingdoms and kings. So kings started searching for them to get them executed. So, but there was this one mathematician, his name was Pythagoras. Pythagoras came from an island called Samos, and he found some patterns in mathematics that we still use now, but he wanted his mathematics to live on. So in order to do that, and in order not to get people in trouble, aside from him being in trouble, he started doing a search to see who would be part of his group. So he would go from town to town doing stuff like this. So pay attention. Ready? Here we go. And do this all in your noodle without writing it down and without saying it out loud. Ready? Here it goes. Think of any number.
9,000.
Okay, let me repeat that again. Without saying it out loud and keeping it to yourself in your noodle. Here it goes again. Think of any number. Triple that number. Double that number now, the new number. Now I want you to get that new number divided by the original number. Yeah, some of you already like checked out a long time ago. Those of you that are still with me, show me with your fingers what you got so far. Who got 6? Yes. What? Everybody's like, what? So guess what? Thank you. If you got 6, you are part of the group. This group was known as the Pythagoreans. They would go from town to town recruiting. They would recruit people that knew how to do math without writing it down, without asking questions, and without shouting it out to the world. So to identify them, as they went from town to town, they said, we're going to do something that we only know. So they created medallions. And in the center of the medallion, guess what it had? Close. It had a triangle. So that's how they were known as the Pythagoreans. Now, why did they use a triangle? Because Pythagoras came up with a pattern that is still used now. Here goes the pattern. He said, with any right triangle, he started off with this basic one. He said, if this right triangle, let's say I label this one 4 units, this one is 3 units, I'm going to see if I can find patterns to this. So then he did this. Look up. He said, okay, I'm going to create a figure here, same figure over here, and I'm going to see how these are the legs. Is that correct? Yeah. How these 2 legs, once I do this, are related to the hypotenuse. Without saying it out loud, look at it first. How are these 2 related to this? Some of you don't see it. Let me show it. Let me give you a step closer. Talk to your neighbor, let them know how that's related to that. All right, so let's see. So he saw, well, let's see. I started off with 3, 4, and this one was 1, 2, 3, 4, 5. He said, and then I heard somebody said perfect square, so I did 9, 16, and 25. So how are these related to this, everyone? They add to become that. But then he saw, wait a minute, can I add these 2? That does not become that. So what can I do to these to make it relate to that in order for this to work? Talk it over to your neighbor. What can I do to these to make this work? Reagan, what can I do to those? If we double it, it becomes a 6. Fatima. Square it. What is 3 squared? 4 squared. 5 squared. So he saw, okay, so if I square it, and then he started adding different numbers, and it worked. He thought, wait a minute, this works. But I want to convey this to people, but with variables. So he labeled the legs A and B, and the longest side. So you near the Pythagorean Theorem now using the variables. That is correct, and that's how he developed the Pythagorean Theorem, which says A squared plus B squared equals C squared. And that's what we use nowadays to figure out lengths of the side of a triangle. So with that said, underneath your steps, I want you to copy example Q. Example Q. Copy this triangle, and the legs are measured 8 centimeters, 15 centimeters, and the hypotenuse is C. The right angle's right here. Okay, so we're going to do this one together so that you can see the process, so that you can come up with your own steps when you write your steps, okay? So if they're asking me to figure out the long side, what would be my obvious first step now that we developed the Pythagorean Theorem? Pablo. You're close, but what would be, like, if you're showing this to someone that doesn't know anything about that, what would you give them? Isaac. Standard form, okay, close. Luca. Write down the Pythagorean Theorem. Step 1, a squared plus b squared equals c squared. Now that we got started with that, what would be step 2? Now, what's another word for putting the numbers? Substitute. That is correct. That would be step 2. So we write 8 squared plus 15 squared equals c squared. And you're writing this down, right, Julian?
Yes.
Now that we have this, tell your neighbor the third step, everyone.
Solve.
Not solve yet.
Solve the square.
Simplify. What is 8 squared? 64. What is 15 squared? 225. And all that equals to c squared. We're not done with simplifying. 64 plus 225 is 289 equals c squared. Now step 4 is what? Solve. How do we leave c by itself? Square root. Whatever we do to this side, we do to that side. Now, let's think as to the answer. Why will I not use negatives? No, because what are we computing here?
A right triangle.
Yeah, but what is this called? A distance. We don't measure distance or time with negative numbers. That's why the answer will only be positive. Square root of 289 is 17. So C equals to 17 centimeters. So that was step 4. So do you have your process done? Yes. 1, write your Pythagorean theorem. 2, substitute. 3, simplify. And 4, solve. Okay, now check this out. Yeah, it's not that bad. Look at this example. Look up, please. You don't have to copy this. What would be the first thing we do with this one? Write the Pythagorean theorem. What is the second thing? Substitute. What would be the third thing? Simplify. And then at the end, solve, taking the square root to find c. We're not going to do that for this one. What I do want to do is this next one, example, megacube. Copy this on the top left of your graph paper, please. Top left. What is the distance between F and G? F is 2, 3, and G is 6, 7. Copy that. And then from there, plot the points. First point is 2, 3. 2, 3, it's right there. The other point is 6, 7, which is right there. Let me zoom in. 2, 3, 6, 7. We need to find the distance from here to here. And some of you are like, do you use slope? No, check this out. Look up. Do you guys see the right triangle? So we need to figure this side, right? What is this side called? C. So that means this is A and B. So what does this side measure? 1, 2, 3, 4. What does this side measure? 4. So what do I do from there? Mel, tell me what to do. Write out the Pythagorean theorem. A squared plus B squared equals C squared. Continue, Havian. 4 squared plus 4 squared equals C squared. Continue, Brody. Simplify, so that's what? Squared. And last step, Charlie, what do we do? Square root, square root. So check this out. This cancels this. We're left with C. But now, is this a perfect square number? So it's approximately, do you know how to find square root of 32? 32 is in between what two perfect squares? 25 and 36. That means it's going to be approximately 5 point something. And how do we find that something? 32 divided by, minus 5, that's 7. And I'll wait for Julian because he's still writing this down. Oh my goodness. 36 minus 25, that's 11. So how many times does 11 fit into 7? None. Add a decimal into 70. 6 times, that's 66. Subtract, that's 4. Into 40, 11, that's 3. So I'm going to leave it at 5.63. And I'm just going to write units. Now, did everybody see this right triangle? Who saw this one on top? Look up. Yeah, so either or. If you see this one, then draw that one, and then label your sides. If you see this one, draw that one. Okay? Well, your home play for tonight is those 10 problems. They're going to be on the video. There is tutoring if I don't see you guys. See you guys tomorrow. Bye.